Have you ever stopped to wonder what makes up the vast, expansive universe? It's a question that has intrigued scientists for centuries. One of the most captivating mysteries of the cosmos is the concept of dark matter. Unlike the stars and galaxies that light up the night sky, dark matter does not emit, absorb, or reflect light, rendering it invisible and elusive. Yet it's believed to make up about 85% of the universe's matter. How do we know it's there if we can't see or touch it? The answer lies in its gravitational effects. Dark matter's presence can be inferred by observing the behavior of stars and galaxies, phenomena that often defy the laws of physics as we understand them. This invisible component of our universe has sparked intense debate and research among the scientific community. While we cannot see or touch dark matter, its presence is strongly felt and its existence a subject of intense debate and research. A team of astronomers, including those from the University of California, Irvine, took on the challenge to unmask this invisible entity. This elusive component of our universe, known as dark matter, doesn't emit, absorb, or reflect light, making it essentially invisible. But despite its invisibility, it has a profound effect on the universe due to its gravitational influence. To probe this cosmic mystery, the researchers turned to the power of computer simulations. The team embarked on an ambitious task, creating a virtual universe that incorporated both normal matter and dark matter. This wasn't just a simple exercise in computer programming. Instead, it was an attempt to recreate the complex and intricate features observed in real galaxies. The goal was to see if these simulations could indeed mimic the realities of the cosmos. They wanted to see if they could reproduce galaxies that looked and behaved like those we observe in our universe. Stepping into this digital universe, the researchers were able to manipulate variables and observe outcomes, something impossible in the real cosmos. The simulations allowed them to create galaxies, watch them evolve, and observe how they interacted with both visible and dark matter. This provided a unique opportunity to test the prevailing theory of dark matter and its influence on the behavior of galaxies. This process wasn't just about proving a theory right or wrong. It was about seeking a deeper understanding of our universe. Francisco Mercado, the study's lead author, explained that their paper shows how we can use real observed relationships as a basis to test different models describing the universe, a powerful tool to discriminate between these models. As they navigated through this simulated universe, the researchers were looking for patterns that would confirm the existence of dark matter. They were on a quest to see if these simulations could indeed recreate the features of real galaxies, which are difficult to explain without dark matter. Their findings? Well, they might just have unmasked the invisible. The quest was to see if these simulations could indeed recreate the features of real galaxies, which are difficult to explain without dark matter. And it appears they have. The results of the study were compelling, to say the least. When we venture into the realm of the unknown, we often encounter findings that stretch our understanding of the cosmos, and this study is no exception. The team of astronomers, including those from the University of California, Irvine, used computer simulations to recreate the dynamics of the universe. They incorporated both ordinary matter, the stuff we can see and touch, and dark matter, the elusive substance that has long been theorized to make up the majority of the universe's mass. Their objective was to mirror the features observed in real galaxies, features that have puzzled astronomers for decades. The rotational speeds of galaxies, for instance, have been notoriously difficult to explain through visible matter alone, hinting at some unseen force at work. The team's simulations provided a convincing answer. The features they observed in their virtual galaxies matched those seen in the cosmos, from the spiraling arms of galaxies to their rotational speeds. But it wasn't just a matter of matching what we see out there in the universe. The study went a step further by demonstrating that these features are more naturally explained by a universe filled with dark matter. The lead author of the study, Francisco Mercado, explained the significance of their findings. He said, "We show that such features appear in observations of many real galaxies. If we take these data at face value, this reaffirms the position of the dark matter model as the one that best describes the universe we live in." So what we have here is a virtual universe created by a team of astronomers that behaves just like our own. And the secret ingredient? Dark matter. For years, dark matter has been a theoretical construct, a necessity to explain the unexplainable. But now, thanks to these computer simulations, we have compelling support for the existence of this elusive substance. The truth is, we are only just beginning to understand the complexities of our universe. But with each new study, with each new finding, we edge closer to the truth. If we take these data at face value, this reaffirms the position of the dark matter model as the one that best describes the universe we live in. But the study did not stop at just affirming the existence of dark matter. The researchers dug deeper, casting their sights on the intricate relationship between visible matter and the inferred presence of dark matter in galaxies. This is a dance that plays out in the cosmos, a tango between the seen and unseen, each influencing the other in ways that are both subtle and profound. Just imagine, all the stars and galaxies we see are just a fraction of what actually exists. The rest, the vast majority, is dark matter. Its presence inferred not by what we see, but by what we don't see. Its gravitational pull, shaping the universe as we know it. But how do we know it's there at all? After all, it doesn't reflect, absorb, or emit light. It's invisible, but its effects are not. And it's this paradox that the researchers were keen to explore. Now, here's where things get really interesting. The observations that confirmed these features were initially conducted by proponents of a dark matter-free universe. Yes, you heard that right. Those who believed that our universe was devoid of this mysterious substance were the ones who inadvertently provided further evidence of its existence, an irony not lost on the researchers. These observations revealed that galaxies obey a tight relationship between the matter we see and the inferred dark matter we detect. This relationship, so consistent and predictable, that some have started to question whether dark matter is simply a manifestation of our incomplete understanding of gravity. But as Professor James Bullock from UCI School of Physical Sciences pointed out, what we showed is that not only does dark matter predict the relationship, but for many galaxies, it can explain what we see more naturally than modified gravity. So the dance continues, with dark matter leading the way, shaping the galaxies and the universe around us, unseen but undeniably present. The study's findings, rather than closing the book on dark matter, have only turned to a new chapter, one that starts with, the observations have shown a tight relationship between the matter we see and the inferred dark matter we detect. So, what does all this mean for our understanding of the universe? This groundbreaking study propels us further into the cosmic abyss, strengthening our belief in the existence of dark matter and its role as a fundamental component of the universe. The research findings lend credence to the theory that the universe cannot be fully explained by the matter we can see and measure directly. Instead, it points towards the necessity of dark matter, an elusive entity, to account for the mysteries that remain unexplained. The implications of this research are profound. It solidifies the position of dark matter within our cosmic model and underscores its role in shaping the universe as we know it. What was once a speculative theory is now gaining traction as a tangible reality, confirmed by computer simulations and observational evidence. But let's not stop at confirmation. The findings of this study are a stepping stone towards a much broader exploration. They point to the need for further research in the field of dark matter to uncover its nature, its properties, and its influence on the cosmos. Will we one day be able to directly detect and measure dark matter? Can we refine our simulations to create even more accurate representations of the universe? These are the questions that now loom ahead, promising to push the boundaries of our knowledge and understanding. Moreover, the study also highlights the interplay between visible matter and the inferred presence of dark matter in galaxies. This relationship is yet another avenue that demands exploration to understand the intricate balance that governs the cosmos. In essence, this research has not only deepened our understanding of the universe, but also sparked a wave of curiosity. It's like opening a cosmic Pandora's box, unleashing a plethora of questions that promise to keep the astrophysics community intrigued and engaged for years to come. This study has not only brought us a step closer to understanding the universe, but also opened up a plethora of questions that promise to keep the astrophysics community busy for years to come.